Let's look at some trick problems. How can these trinomials be tricky in any form? Well, first, on number 6, you might notice that this trinomial has powers of x to the fourth and x squared rather than the typical x squared and just x to the power of 1. So here's how we do this step. We start the same way. We look for a GCF. Well, there is none. So now we go to the x method. We still do a times c, so we'll have a value of 20 and then a value of negative 21 underneath. We look for factors that multiply to be 20 but add to be negative 21. 1 and 20 are actually going to be the numbers. Though they do multiply to be positive, right now they do not add to be negative 21. So we need to make both of these negative. Now these would still multiply to be positive 20 because a negative times a negative is positive. So those are my values. Now I follow the rule. I take my first term, which is 2x to the fourth, but I'm going to divide the power by 2. So it'll be 2x squared and 2x squared there. And now I plug in my values, negative 1 and negative 20. I go to bottoms up technique, which means I just look for something that can go into both of these. Well, nothing simplifies that, since only one goes into them, so I go over here. Both of these could be divided by 2. So my actual two factors will be 2x squared minus 1 and x squared minus 10. Now that's the factored form. We will learn in the future that we can actually factor these again. And if we wanted to do so, these are binomials. There's going to be a shortcut for that, but we're not going to focus on that today. All right, this one. Now, something I noticed right away is that there is a GCF. Now, what value can go into all of these? Well, 3 definitely can. But not only that, they all share an x. So this time my GCF is 3x. Now let's divide each of these by 3x and see what that leaves us with. Now remember that I can't just make that 3x disappear. So I'm just going to put it in front and put the rest in a parenthesis. So what am I left with? I'm left with, well, 6x cubed divided by 3x is 2x squared. And then over here, minus 21x plus 20. I'm sorry, I put 20. I can't do math. 30 divided by 3 is 10. There we go. Okay, now let's go through the process of x method. So I draw my x. Oh, and I don't want to confuse anybody. This has become my new a. This is my new b. This is my new c. So I have 20 on top, negative 21 below. Again, my factors are factors of 20 that add to negative 21, just like here, negative 1 and negative 20. I need to keep the 3x out front, but now I have two new binomials. It's going to start with 2x, and over here, 2x. Now remember, the reason this is 2x is because you divide that power by 2. So 2x and 2x. Now I plug in my numbers, minus 1, minus 20. And we see that, again, I can divide this by 2. Let me switch colors just so you can tell it's a new step. I can divide this by 2, divide that by 2, and I'm left with 3x times 2x minus 1 times x minus 10. So that's how you can get answers that look alike or might look totally different. Maybe the problem looks totally different. That's kind of how they get tricky, is they'll either switch up powers like this, or here they'll have a GCF of the value x.